is going to be giving a lecture, which I think is going to be very nice. I think, in fact, it's this week on the last 10 years of advances in the field of CC coupling reactions, which I think will be a nice addendum to what I'm presenting here, because this is just really the basic overview. All right, let's see. Let's start with let's look at that. That's already, well, let's build in a fourth step for good measure. Yeah, check it out. All right, let's look at it. Let's look at it from back to front. If I were to give you this molecule, this is a long alkyl chain attached to a phenyl ring, right? I mean, I bet you would never imagine that you could do it using this disconnection sequence here. So if we go back, right, remember retrosynthesis. This is a possible disconnection sequence, isn't it? And so now we're combining all sorts of things. But so you can look at it from back to front or front to back. Let's start from front to back. Or let's start from the beginning. If I start with cyclopentene, how can I get this guy here? Ring opening metathesis. And if we're lucky, it will work with grubs. What else can we use besides grubs? Tungsten, molybdenum, so the Schrock system. All right, what's the next step? Or you can use a coupling reaction. Could you use metathesis?
Well, why not?
Alkene metathesis, yes. So you have a choice. You can either use alkene metathesis, or you can do a CC coupling, a Heck type coupling, right? Alkene coupling. So you have something like this. You couple this with vinyl X, and you get that. Typical classic Heck coupling. Next step. What are we doing there?
More coupling?
Yes, more coupling. What type of coupling? Again, a Heck coupling.
How do you see that?
Yeah,
Like,
how do you
I don't understand the difference between different couplings. Like, what the difference?
Well, you could either use a Heck or you could use a Suzuki, because remember, a Heck coupling is with a aryl halide and an alkene, or an alkene halide and an alkene. Right? That's Heck. Suzuki is again an aryl halide or an alkene halide. It's always an sp2 halide with a B.
Could you draw it? Like,
All right.
maybe, because I don't really.
All right. So Heck. In fact, I have it on the slide here. I know this is quite a lot to. I actually have a nice slide at the end, which I will now present, which says it all. Because I know it's overwhelming. Modern Cat Chem, lecture 7. So here from this very nice paper from Nicolau, they have a very nice, oh no, this isn't working. System on. Right, we'll be on in a second. We will have a look at that, but let's just, while that's booting up, let's see. So you could basically do a CC coupling to get this aryl group onto this alkene, and what's the last step?
Hydrogenation.
Yes, that's kind of silly, right? Hydrogenation, what catalyst would you use?
Radium.
So-
Nickel.
Rainy nickel, or
Palladium.
palladium carbide, or
Platinum.
what?
Platinum.
Platinum, or you can use something called Wilkinson's catalyst, which we're going to discuss hopefully next week, and I don't know why this projector is not switching on. It is most disturbing. Oh, there, I think it's coming back to life.
It's like a coupling reaction more selective than a metaxilase reaction, because because we have several double bonds. Is it better to use one or another?
Yes, that's a very good point, Nicole. We're going to definitely, in this Mickey Mouse invented situation, we're going to probably have problems with selectivity, exactly. So here, for example, of course we're going to have problems, well there we won't have problems with the selectivity because it's symmetrical, do you agree? So here, we should selectively get the product. In the first head coupling, but the second head coupling might be problematic. Do you see that? Because it could couple to this side here, so selectivity is going to be an issue there. So in that case, you might consider using rather alkene metathesis, and if you do alkene metathesis on this guy here, you might be able to use steric arguments to sort of drive the selectivity towards doing alkene metathesis, which will be difficult because, but you've got to take selectivity into consideration. Right now, I just want to see if we can apply the basics.
Can I couple to the internal alkene as well?
Yes, that's the other problem. You might get ring closing metathesis, right? Instead of cross metathesis. That's another problem.
With the Suzuki or head coupling to the internal alkene, is that not favorable?
That might also happen. Yes. We saw that in that example in the lecture now moments ago. Remember where they did that forming that 8-membered ring by an intramolecular head coupling. Anyway, here's an overview of all the different couplings you have. It is quite overwhelming, but you see, for a head coupling, we're taking an aryl, a benzyl, or a vinyl halide, and we're essentially reacting it with an alkene. Okay? The alkene can be decorated with different groups here, but it's essentially an alkene. And what happens is, you couple the alkene H to the R4. That's the basic reaction of a head coupling. The other one we did today is Suzuki. It's basically the same thing. You're just using a different reagent. Do you see that? But ultimately, they're CC coupling reagents. The advantage of a Suzuki reaction is you have you can couple more things. Like you can also couple an alkynyl. But ultimately, you can use either to do the sort of coupling that we. So this is a very, very nice overview of all the different coupling reactions. And next week we're going to look at Stiller, Negishi, and Sonogashira as well. Sonogashira is alkyne coupling reactions, right? But but don't worry about that now. So different reactions have different transmethylating reagents. You see that? Essentially. And with a Stiller reaction, which you're also going to do, you use a tin reagent to do the transmethylation. But I just want you to realize now at this point that this is very dense with information, and so try and stay on top of it, right? Any questions? Right, how do you guys feel about the midterm on Friday? Are you ready for it? Any questions? Any other questions, guys? No questions? Alright, no questions. I'll see you shortly then for the tutorial. And today we're going to look at this paper from this one of these seminal papers about head coupling and analyze it. So I'll see you guys.